All right, our next fraction topic comes by a few different names that you'll see. And I want to make sure that you understand that these are all the same thing. You are just going to see this written different ways. Today we're going to talk about reducing fractions, which is the same thing as simplifying fractions, which is the same thing as putting fractions in lowest terms. When you see these three words here, these are all the exact same thing. It's just a different thing to call each one here. Okay, and you will see all three in some form at some point. So just understand that when you see any of these three going with fractions, we're doing the same thing here. And what we're doing is we are dividing the top and the bottom of the fraction until there isn't anything we can divide both the top and the bottom by. And we'll do plenty of examples so you understand what I mean. And this is a form of an equal fraction. When we do this, we make an equal fraction because we're dividing the top and the bottom by the exact same thing. We're not going to draw the pictures for this section, but just know that anytime we make an equal fraction, or anytime we reduce a fraction, simplify a fraction, put a fraction in lowest terms, we are making an equal fraction. But again, we're just dividing the top and the bottom by the same thing until we can't divide the top and the bottom both by the same thing anymore. Alright, I've put both of these fractions up here the same thing, 24/30ths. I'm going to show you two different ways to reduce these down. Depending on how good you are at your factors or knowing what goes into these numbers, it might take you more steps than other people. So we'll just have to see how this goes here. So what I'm looking for is I'm looking for a number that goes into both 24 and 30, and it's got to go into it whole. So if you do not know a number, I can look at these and know they're both even numbers, so 2's got to go into them. So what I'm going to do is I'm going to divide the top and the bottom by 2. Now I'm going to get 24 divided by 2 is now 12, and 30 divided by 2 is 15. Here's my new fraction. I've got an equal fraction here. But the idea of reducing or putting in lowest terms or simplifying is we keep dividing until we can't do it anymore. We get it in its smallest form or with the smallest numbers. It still takes the same amount of space, but get it in the smallest form we can. So I need to find something that goes into 12 and 15. I know that 3 can divide into 12 and 15. So if I divide both of these by 3, 12 divided by 3 is 4, 15 divided by 3 is 5. Now I've got 4/5. This is our final reduced form here. Because there is not anything that can go into 4 and 5 besides 1 to make the numbers any smaller. 2 goes into 4, but it doesn't go into 5. 5 goes into 5, but it doesn't go into 4. So this is our final form here. Now, a quicker way to do this would be if you know a bigger number that goes into both of these. The bigger the number you know that goes into both of these numbers, the less steps you have to do. So for instance, I know that 6 would go into both of these. So if I divide by 6 right away, 24 divided by 6 is 4, 30 divided by 6 is 5. There's my answer right away. Nothing goes into 4 and 5. Besides 1, and it only took me 1 step instead of 2 steps. Okay, you can do it either way, it's fine. If you can't think of 6 to go into both of these, start with 2 and just whittle your way down. Alright, here's another example, and I'll show you 2 ways to do this. 9/18 and 9/18. 9/18, I need a number that goes into both. If you can't think of the biggest number, any number will work as long as it goes into both of them. I know that 3 times 3 is 9, 6 times 3 is 18, so 3 goes into both of them. So if I divide by 3, 9 divided by 3 is 3, 18 divided by 3 would be 6. Now, I've got to go further with this because I know that 3 goes into 3 and 3 goes into 6. 3 times 1, 3 times 2. So I divide both of these by 3, and I'm going to get 1/2. That's the lowest I can go right there because the only number that goes into both 1 and 2 is 1. Now if I want to do a faster form here, I'll just divide both of these by 9. I know that 9 times 1 is 9, 18, or 9 times 2 is 18. So if I divide by 9, 9 divided by 9 is 1, 18 divided by 9 is 2, and I get my answer right away with just one step. All right, last example before you try this on your own here, 16/40ths. 16/40ths we can do two different ways here. If I'm confused and I don't know something that goes into 16/40ths, if you've got an even number, which we do, 16 is an even number, 40 is an even number, just divide by 2. Okay? 16 divided by 2, 40 divided by 2, that would be 8/20ths. Now, we got to go further than this here. So since they're both even, if I wanted to, I can just keep dividing by 2 would be fine. Divide it down by 2 again. I'm going to give 4/10. And they're still both even numbers, so I still should be able to divide both of them by 2. 4/10, cut both of those in half, divide by 2, we're going to have 2/5. That would be my final form because there's not a number besides 1 that goes into both 2 and 5 equally. 16 and 40. Now, there's actually other ways we could do this here. I'm going to do this 3 ways actually, just to show you've got options. I'm going to do 4 times 4, and then 10 times 4. So if I divide this by 4, I'm going to get 4 and 10, and then we're back down here where we had 4 and 10, so we just divide by 2 and we get 2/5. Over here, if I want to do the quick way, I know that the biggest number that goes into both of these is 8. 16 divided by 8 is 2. 8 times 5 is 40, so 40 divided by 8 is 5. There's your answer. We got the same thing, and if I would have done this completely all the way out, that would have also been 2/5. The same thing, it doesn't matter whether you know a big number that goes into it or you just have to whittle it down by using many small numbers. Either way will work out the same. Here are your 4 practice examples for this. If you are not very good at your basic facts or not very good at factors, I would suggest on your computer you getting up a multiplication table to make this process a little easier, and then you'll become better with your basic facts along the way. Try these 4 problems. Try to reduce them, put them in lowest terms, simplify. It's all the same thing, and then turn the video back on and see how you did. I will give you a warning on this one. One of these is already reduced all the way down. All right, let's see how we did here. Looks like we've got 6/8, and I think that the only way we're going to be able to do this is just to divide by 2. 2 goes into both of those. 6 divided by 2 is 3. 8 divided by 2 is 4. I know I'm done here. It's 3/4 because the only number that goes into both of these equally is 1. 2 goes into 4 but doesn't go into 3. 3 goes into 3 but doesn't go into 4. So 3/4 is our last final reduced answer. 22/30ths. 2 might be our only option for this one as well. If I divide this by 2, 22 cut in half is going to be 11, and then 30 cut in half is going to be 15. My experience with the number 11 is that it's a prime number, meaning only 1 in itself can go into it. So for that, only 11 times 1. This we could do 1 times 15, and we could do 5 times 3, but 5 nor 3 go into 11, so this is my final form here. Over here, I think there's probably a couple ways we could do this. The long way would be to just keep cutting it in half because they're both even. Well, we could do that for a little bit here. So if I divide by 2, 18 divided by 2 is 9, 90 divided by 2 is 45. 3, I think, goes into both of these. So if I divide this by 3 and divide this by 3, 9 divided by 3 is 3, 45 divided by 3 is 15. Looks like I still have one more step to go because I can put 3 into both of these equally. Divide by 3, divide by 3. 3 divided by 3 is 1, 15 divided by 3 is 5, 1/5. Now, if I do this a little quicker here, I know the biggest number that goes into both of these is 9. So if I divide by 9, 18 divided by 9 is 2. 90 divided by 9 is 10. Now, funny, 9 wasn't the biggest number that could have gone into both of these. I guess now that I think about it, 18 could have went into 90, and that would have been faster. But we can just keep doing it this way. Now into both 2 and 10. Looks like I could divide both of those by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. Last one here, we got a couple of prime numbers, 7 and 17. The only way I can get 7 is 7 times 1. The only way I can get 17 is 17 times 1. So the only common number there between both of those is 1. And if the only thing that you have left to put into these is 1, it is already reduced, or it's simplified, or it's already in lowest terms. So I'm just going to circle this one. Nothing needed for this. It's already reduced all the way down.